The topic is on unit operations in food processing, and the topic is about size reduction techniques. Earlierly in the previous session, we have seen about what is size reduction equipment, what are various machines which are used for size reduction equipments, what is the crusher and primary and secondary crushers, and what is the working principle and crushers, what is a jaw crusher, how to protect the machine, what is the working of jaw crusher, what is the capacity of jaw crushers. From here onwards, we'll be seeing out what is a gyratory crusher. Gyratory crusher, it works on the principle of compression. Construction. It consists of two vertical cone shells, and the outer shell having its apex in downward direction, while the inner cone is positioned with its apex upward. The inner shell acts as the crushing head, which is the form of tunicated cone and is mounted on an oscillating shaft. The upper end of the cone is held in a flexible bearing while the lower end is connected to an eccentric. The eccentricity causes the conical crushing head to oscillate between open side setting and closed side setting OSS and CSS discharge openings. Hence, the crushing action takes place around the whole of the cone and is continuous. The eccentricity also determines the capacity of gyratory crushers. The material to be crushed is fed from the top and is crushed between the stationary outer shell and the crushing head. They are crushed several times before being discharged from the bottom. An additional crushing effect occurs between the compressed particles, resulting in less wear of the crusher materials. This is known as intraparticular crushing. The material to be crushed is charged from the top of the conical head gyrates inside the casing. At any point on the periphery of the casing, the bottom of the crushing head moves towards and thus away from the stationary wall. The solids caught in the V-shaped space between the head and the casing are broken and rebroken until they drop out from the bottom of the machine. The speed of the crushing head, it usually lies between 125 to 425 gyrations per minute. Features of the gyratory crushers. It is continuous in action. Fluctuations in stresses are smaller. Load of the motor is nearly uniform. Power consumption per ton of the material crushed is smaller. It requires less maintenance than jaw crusher. Since the capital cost is high, it is suitable only where large quantities of materials are to be handled. Comparison between jaw and gyratory crushers. Jaw crusher, it's a reciprocating motion. Gyratory crusher is a gyratory motion. In jaw crusher, it is a discharge is discontinuous. Here, the discharge is continuous. In this, it is a primary crusher, where it is a secondary crusher. In jaw crusher, the load on the motor is not uniform. However, in gyratory, the load on the motor is uniform. More maintenance is required for jaw crusher. However, for gyratory, less maintenance is required. The power consumption per ton of material for crushed is more. However, in gyratory, the power consumption is less. For jaw crusher, the capital cost is low. However, for gyratory, the capital cost is high. It has smaller capacity when used to produce a small size reduction for jaw crusher. However, gyratory crusher, it requires a large capacity. Hence, this is the comparison between jaw and gyratory crushers. Roller crusher. The size reduction is achieved by compression. In this, the smooth roll crushers consist of two heavy metal rolls of the same diameter placed side by side, each other on the horizontal position. The rolls mounted on the shafts are rotated towards each other at the same speed. One of the shaft moves in the fixed bearings while the other moves in the movable bearings. The clearance between the rolls can be adjusted according to the size of feed and size of the product required. One of the rolls is directly driven and the other by friction with the solids being crushed. The rolls have relatively narrow spaces and are large in diameter, therefore, they can nip moderate large lumps. The material fed to the machine is reduced in size by compression and discharged from the bottom. The machine is protected by spring loading, that is, by mounting the bearings of one of the roll shafts against coiled springs against damage due to tramp and very hard material. When used as crushers, roller mills have diameters of up to 2 meter with lengths of up to 1 meter and speeds of rolls varies from 50 to 300 revolution per minute. The reduction is in the order of 3 or 4 to 1 that the feed reduces its average size of 1/4 of its original size. Here is the diagram of the roller crushers. Working. The material to be crushed is fed from the top. As the roller rotates, the material gets caught in between them and gets reduced in size by compression and discharged from the bottom. In industrial applications, it is used in which fines are to be minimized. They are employed for crushing of oil seeds, coal, phosphate rocks, abrasive material, petroleum, and explosive materials in gunpowder industries. Selection of crushing rolls. While selecting the rolls for a certain purpose, it is necessary to know the size of the feed, size of the product, the amount of material to be handled, and the coefficient of friction between the roll surface and the material to be crushed. Capacity. The theoretical capacity of a crushing roll Q in kg per hour is given by Q equals 60 pi d1 d3 bn rho, where b is the breadth of roll face in meter, n is the number of revolutions per minute in rpm, and rho is the density of the material to be crushed in kg per meter cube. The volumetric capacity is affected by speed, nib, diameter, and breadth of the roll face. Actual capacity is usually b by n, which is 10 to 30% of the theoretical one. In this we have seen the capacity of crushing rolls, and from the next session we will be seeing about grinders. Thank you.